ELIC Research is a group within the physics department of Otago University. I mean, we started off doing electronic stuff largely, but nowadays what we largely do is algorithms and statistical modelling and stuff like that. And the electronics that we build is merely to support that research goal.
The major project we do is around measuring the weights of cattle using weighbridges, ground forces, and trying to do that in a super smart way so that the cattle can unobstructedly walk over a weighbridge and we can work out what they weigh. So that project doesn't sound much like physics, but it turns out that if you model how cows walk using physics, you can weigh them better. And so there's a lot of very difficult physics in the locomotion of cattle. So that's a kind of a project where we're developing a sensor, that's the weighbridge, which uses fancy physics and fancy statistical algorithms to make better measurements. We do that in other areas as well. We build a radio telescope where we're developing new algorithms to make, once again, measurements in a clever way and to measure unique things, in this case, transient events. All of these projects use relatively standard equipment, but try to make smarter measurements. So with the SkyPi, we're using a relatively standard camera, something that's pretty much straight out of a cell phone, to make measurements about meteorites in the sky and trying to use this cheap hardware, roll it out over schools as an outreach project, but also learn interesting things about meteorites, how often they get close to the ground, whether that's changing, just that kind of thing. And wildlife tracking, that's another thing where we've been quite involved for the last, I'd say, 8 or 9 years, maybe 10, where we've been developing algorithms to come up with the location of animals or anything else from very short measurements of signals from satellites. So we've developed a tag that can figure out a position every 5 minutes for about 200 years with a very small amount of solar power with a standard little SD card. It can do that because it captures 10,000 times less data than a GPS unit that is reporting positions to an observer would do.
The coffee machine. Yeah, the coffee machine is a extremely important chunk of machinery.
So I drink what a snobby barista would call milk soup.
It's been amazing, just in our ability to, when we have guests to our lab, people might be funding agencies, we can sit down, we can offer them a coffee, we can talk about our research, and I think it gives us a little bit of mind share. They're like, oh, those are the guys at the coffee machine.
I like a milky coffee, thank you.
Even on that level, it's been very effective, but it's also very effective within the research group. People will come in here at 11 o'clock or at the start of the day, they'll talk about random things and they'll talk about their research, they'll swap ideas, and it's a very integral part of how we do stuff, and I think it's been very successful.
So it's one of the things I like about the group is that it's by desire to join, if you like, that anybody who wants to be part of what you might call ALEC research is welcome, and part of the bonus of that is the coffee machine. Our group is all about functionality, and indeed one of the things we get involved in is the modern version of signal processing, which is a traditional electronics thing. And so that makes a kind of a functionality that students often find appealing. So it allows you to do funky stuff, unlike a lot of other areas where you can do funky stuff in theory. In electronics, you can build a thing that does that funky stuff. And so our students are very interested in that.
So Max is a PhD student. Max is on a scholarship. He's from Germany. He's got a background in a lot of computing, which is excellent, and a background in physics. And he's developing the algorithms for this radio telescope. And these algorithms are used everywhere. They're used in medical imaging for CAT scanners, they're used in ultrasound imaging, they're used in radar, and they're used in radio telescopes. At the moment, the more receivers you add to the array of receivers, the computation problem gets nearly impossible very quickly. So if you can develop algorithms that do that at low power without a huge supercomputer, you will be able to make self-driving cars that work better. You'll be able to make medical imaging stuff that gives you better diagnostics from CAT scanners. So I think overall what I'd like to do is carry on with the sort of range of projects that we've got, taking on projects around the weighing of other things other than cattle, taking advantage of technology we've already developed in a slightly different area. So it's, if you like, we've done the sort of research, we've got it in the bank, now we can reuse it in other places, which will help companies to make better products or just provide interesting research objectives.